Okay, so I'm going to slowly explain this as you guys have your steps in front of you. But what I want you to realize is that this is just one of our normal reactions. This is the one that we've been doing actually most recently, which is double replacement. So DR means double replacement. And what we're going to do is we're just going to look at the reaction that the double replacement kind of did on its own. And we're going to really specifically narrow in on just the ions that are causing precipitation to occur. So how many ions come together to form a precipitate? 2, right? Well, in a double replacement reaction, how many ions do we have total? Anybody? 4, right? 2 from reactant 1, 2 from reactant 2. They do a switcheroo. Maybe there's a precipitate form. The other one's just what? If we don't form a precipitate, so like this, say, first product is a precipitate. What's the second product going to be? Not precipitate, so what's the word for that? If it doesn't precipitate, what do we write next to it to say it doesn't precipitate? Well, we don't put no PPT, we put something else. So there's an A. AQ, right? Aqueous. So we put aqueous because it's just a solution, and this solution has ions dissolved in it, because aqueous means dissolved in water, right? So what we're specifying here in a net ionic equation, or an NIE, is just the ions that are involved in precipitation, because that's where the real magic's happening, right? That's where the real chemistry's happening. The other ions that are just floating in aqueous solution aren't doing jack, right? They're not doing anything. So they're sitting on the bench. They don't do anything. So that's why we don't really care about them at the end of the day, because when we write the NIE, the net ionic equation, we just care about the players in the game, which are the ones that are making the precipitate. Okay? So all these steps are just going to take us down to the specific reaction that's actually occurring in solution. So what we do is we call those ions that are in aqueous solution spectator ions, because what are they doing? They're just watching that reaction happen. They're just hands off. They're not doing anything. So, okay, so playing the game, baseball, football, volleyball, whatever you want to do. Who are the spectators? Where are they at? They're in the stands, on the bleachers, right? The ones that are actually playing the game are the ones that we care about, which are the ions that are going to form this precipitate, per se. We can do this for double replacements, definitely. We'll do this for some single replacements. We have a lab tomorrow, and that's going to be where we see it in some single replacement reactions. But what we do first is determine the solubility of each reactant and product. Generally, it will be for the products, because I'll generally tell you the reactants, and the, you know how I phrase it, like a solution of calcium chloride and sodium phosphate. So a solution of means what? Precipitate or aqueous? Aqueous. So the solution of, like when I start to say something is a solution, immediately you're thinking aqueous. So most of the time the reactants are aqueous. The products can either be precipitates or aqueous. And how would one figure that out? You don't just look, like when you're looking at the reaction you've written out for yourself, how do you figure this out? Solubility rules, right? So you must use the solubility rules, and that's going to be on a reference table, right? So you're going to be able to use that reference table and as you need it. So once you figure out the solubility of each of the reactants and products, you're going to separate or ionize, like, well, I'm going to show you how to do that in a second, anything that's soluble. So if it's soluble, do we put PPT or aqueous next to it? Make a choice, loud and proud. So soluble means soluble means dissolved in solution. So is that PPT or aqueous? Aqueous. Most of us were saying aqueous. A couple were saying PPT. So the ones that we put AQ next to, we will ionize. The way we ionize, and I use this as a specific example. NaCl, it came together as 2 ions, right? What were the 2 ions that came together? Sodium ion, 1 plus, and chlorine ion, 1 minus. What I do is I literally just write these as 2 separate ions now, just to say that I've ionized this compound. Let's ionize another one. Let's not ionize sodium phosphate. Turn to the person next to you. What's sodium phosphate? Say it out loud. Sodium phosphate. 3, 2, 1. Back to me. Sodium. Na, not S. That is sulfur. And then phosphate. PO4. 3 minus goes up here, right?
Yeah.
No.
It goes.
Okay, making sure we're crisscrossing. And then phosphate has a 1 next to it if I wanted to write it. But so that's sodium phosphate right there for you. All right, so when I ionize this, I don't want to be a home wrecker. Polyatomics are happy families, so do not rip this polyatomic apart. You basically take the sodium ion, to make sodium Na1+, but how many sodium ions do I have in this formula? 3 of them, so I put a 3 in the front to say I have 3 ions. Okay? And how do I write phosphate as an ion? P O 4 -3. Good. How many phosphate ions do I have here? 1, so I could put a 1 in the front just to say I have 1 of them. But all I'm doing is ripping the ions back apart to their original form, but I'm using the subscript to say how many of that particular ion I have, which is why I put a 3 in the front here, because I have 3 sodium ions in this compound. So this is ionization. We're going to apply this now in an example. Before I do that. So now that I've gone through this part, ionization, what I look for on the reactant side and the product side are the exact same ions. If they are exactly the same from start to finish, did they change in the chemical reaction? No. Did they play in the game? No. What did they do the whole time during the reaction? They just watched, right? They spectated. So that's the idea that we're calling them spectatorons because they're not doing crap, and we're just going to cancel them out to say that they are no longer important in this reaction. So I now have the net ionic equation given to me. Okay, this will make more sense when we do the reaction. Ready? So we're going to do this one. Write down, with the person next to you, write down these 2 reactants. If you have a PR table, you might need it more. Yeah. Go ahead and do the double replacement. Go ahead and do the double replacement. No. 2. Where's that 2 coming from? Alright, back to me. I hear some good things, so let's make sure we hit the highlights here. We notice that we have an ionic compound and another ionic compound. This is a telltale sign of what type of reaction? What kind of the 5 types of reactions? Synthesis, decomp, single, double, and combustion. This is a double replacement. So you know the cation has to pair with the what? The other anion. So PB and I get together, right? So they make PBI. Where's this 2 coming from? Because that's let's charge. Don't forget, you have to crisscross charges every single time you form a new compound, specifically because these are all ionic. And then the other ion, cation, K plus is going to get with who? Nitrate. So that's going to make K1 plus, nitrate 1 minus, crisscross. What do we make? Potassium nitrate, right? KNO3. All right, balance this baby out. What do I need? 2 in front of potassium iodide and
2 in front of the potassium nitrate.
Beautiful. We're good, right? Okay. So I've got my balanced chemical equation. Step 1, BCE. If you're a step person, I'm writing them right here. Step 2, solubility. We need to understand the solubility rules. I know you don't have them right in front of you, so I'm going to help you out here. All nitrates are soluble, every single one of them. So I would put AQ next to the nitrate to say it's going to be ionizing or soluble in solution. My pen is off by like an inch, so I'm sorry it's a little bit messy. All iodides or halides are soluble except for silver, lead, and mercury. So this is an exception to my soluble rule, hence making it what? A precipitate. Good. Okay. And then I'm telling you that these are solutions just off the cuff. Put AQ next to these. AQ. Okay. So now we have our solubility listed for everything. We have a balanced chemical equation. Step 3, we're going to ionize the aqueous ones. Oh my goodness, this pen. I need to fix my board. Ionize aqueous compounds. Okay, so I'm now going to take these and rip their ions back apart. So I'm going to take the lead and the nitrate and split them into 2. So what's the lead ion's charge? Lead 2. You already saw that in the equation I had. How many nitrate ions do I have? 2, because there's a subscript of 2 there. So put 2 nitrate ions. And I'm adding them together because I'm still kind of collectively saying all these reactions are added together. Okay, I'm going to ionize the potassium iodide as well. So split that into 2. What's the first ion? But in the front we have a 2, right? So this means I have 2 potassium ions and 2 iodide ions, right? So I'm going to distribute and put 2K plus what? 2I charge? Charge? 1 minus, right? Okay, so now I've taken care of this aqueous and this aqueous. I've just broken them into 2. So I've re-ionized them. You guys with me?
Yeah.
Okay? Now, I am not going to touch this precipitate because it's not aqueous. I'm going to put a little cloud or a box around this to note that I'm not going to touch this for this this ionization process. Keep this exactly the same way it is written as now. So PBI2 precipitate, do not touch it because it's not aqueous. And then tell me what I'm writing for the last bit here. 2K what? 2K what?
2 and 1.
Plus 1 charge. Remember, they're ions. Make sure you put your charges. And then, and what? 2NO3, 1 minus, good. Because those are ions. Ions are different than solids. Okay, guys. Who are those lazy spectator ions who are not doing anything in this reaction? They're just watching. Who's not doing anything? Who's not making the chemistry happen? No, they're the ones that are like making it happen. They're like, hey, look at me, I'm precipitating. I was a single ion and now I'm a single ion and then boom, I precipitated. They made something happen, right? They're the like VIPs, MVPs of the team. So who's not doing anything? Potassium's like, hey, I'm K plus, how are you? Oh, I'm still K plus, huh? Didn't do anything, still exactly the same. So cancel that out. Notice that I had 2K pluses, so it's exactly the same on either side of the reaction arrow. Who else is like that? Yeah, 2 nitrates are like, hey, I'm here. Oh, I'm still here. I didn't do anything in this reaction. Look at me. So they're just sitting there and not doing anything in the reaction. Those are called spectator ions. So the ones I have here in black are spectators. Okay, so who are the real players? PB what? 2 plus ion, and not just I, 2 iodide ions, they made the reaction happen. They're like, hey, now we have made this precipitate. So pretty much this is the only thing I care about. This is the net ionic equation. And net just means like total at the end. Like if I gave Cam $10 and he gave me 5 back, what was his net gain? $5, right? We don't care about what happened. Like, hey, I gave him 10, he gave me 5, and then we played rock, paper, scissors, right? We don't care. We just care about the end product, which was his gain of $5. So that's why this is the end total we care about. Okay? We will do more of these at the end. We're gonna do our lab now, okay? So in terms of what I want from you guys is we're gonna walk through the procedure real fast, but I have a printout. I have a printout of the data sheet for you. Austin, take one for Zane, his name on it, please. All right, there's extras. Evan, I'll give them. Okay, extras for one. All right, eyes up here. Eyes up here. You notice I already put purpose of the lab, and you're going to fill in that blank spot, right? Okay, so quick overview. This is in your lab notebook. It's called Types of Reactions Lab. What are the 5 types of reactions? Anna, give me one. With me? Double replacement. Give me another, Jacob. Single replacement. Give me another, Cam. Synthesis, Hallie.
Decomposition.
and Aaron. Combustion. Okay, so we're going to see 4 of the 5 types of reactions in here. Notice in the discussion right here, I tell you the ones that we are going to see. So when you're labeling your types of reaction in the procedure box over here, what are you not going to put? Look on the board. Notice I don't have combustion here, so you cannot put combustion. Don't make that mistake, okay? All right, so as you can see, you have part A. One second. All right, board. Ooh, okay, so we have part A. Part A is going to require you to grab a piece of magnesium ribbon. It's like a little strip of magnesium. That piece of magnesium ribbon, you're going to look at the properties first, and then you're going to hold it with crucible tongs. The crucible tongs are kind of look like what? Tongs, right? Do they have the rubber on them or not? No, the rubber would burn in the Bunsen burner. Please, like common sense, right? Don't put anything that's going to burn in the Bunsen burner. But you're going to hold your little teeny piece of magnesium ribbon over the Bunsen burner, and it's going to cause some reaction, and it's going to be really, 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 really bright. Do not stare at it, okay? And also, you're going to, basically, you'll have, I'll help you guys when you get back there. You have your watch glass. What's the watch glass look like? Like a big magnifying glass, like a monocle. Your watch glass will be on the table. You'll be holding your Bunsen burner, I'm sorry, not Bunsen burner, holding your crucible tongs, catch your magnesium ribbon on fire, hold it over the watch glass. Don't hold the watch glass with your hand because this is on fire. You don't want your hand underneath that. Got me? Okay, so basically though, if you do drop the burning metal on the watch glass, it might crack and burn the watch glass, so just be careful with that step. That's really the most hazardous step there, okay? First step, okay? Next one is pretty simple. You guys can read that. That's as is. I only have 2 iron filing stations, which they're right behind Emily and Savannah. So I'll just kind of direct you guys there when we get there, but I have 2 scales set up for that reason. Part C is pretty easy to follow, but part D, you'll notice it says fill a dry test tube a quarter full with solid sodium bicarbonate. Heat the sodium bicarbonate in the flame of the Bunsen burner. Remember to move it around and hold it at an angle. So that looks like this. Okay, hold on. Looks like this. So you'll have your Bunsen burner here. You'll hold your, not with a ring stand, you won't hold your test tube with that. What will you hold your test tube with? Test tube holder, right? And you'll hold it at an angle, and you'll be looking for some sort of chemical reaction. After that process is like starting to occur, you'll take a popsicle stick, which I call a flaming splint, and your popsicle stick, it'll be on fire, okay? It's on fire. So you will have put in the Bunsen burner, holding your popsicle stick on fire, and you're going to insert the popsicle stick into the mouth of the test tube. Not all the way down here, don't go all the way down, just into the mouth of the test tube and make an observation on what happens there, okay? The idea, though, is that you can converse, you're making observations, you can discuss what you see, and then you can classify the type of reaction. I think everything else is pretty self-explanatory. I'll help you guys when you get to step 4. You guys remember how to fill a filter? We just did this Thursday. Make sure you filter solids. No solids go down the sink, right? That's just about lab practice in general. Okay, let me tell you your lab groups. Hold on. Oh. Okay, so there's your lab groups, same as last time. Go ahead and make it to a lab station. Go. So you need goggles on. Get your lab notebook out and let's start our purpose. We have an hour, so we should be good. behind it. Like reaction. I want to see you getting materials out for the step 1, so I know that you're comfortable to start step 1. I'll hand out my needs. You also need to set up your Bunsen burner, and I'm not going to remind you of that. You guys have a lab in front of you. You need to run back to that lab. It's going to be like the beginning of the lab.